Okay, I think it's 7, so I guess we'll begin. So, I'm going to do a little bit of review on the exponential and logarithmic functions. So what I have, our first two questions, we're going to recap the logarithm laws, how to expand and how to simplify expressions. Then I have a graphing question using mapping rule, and then I have an equation where we will also go over restrictions. Okay, so we're going to start with the log laws. So as a reminder, when you have multiplication inside of your argument, so your argument being this portion right here in the brackets, we can expand that out into two logs with addition. And if we have division in the argument, that expands out to subtraction of two logs. And finally, if your argument has an exponent, that exponent can be brought down in front of the log like a coefficient. So for this first example, I'm going to expand the logarithm into multiple logs, and I am going to take it in a few extra steps just to recap the laws. So first thing I noticed, the x cubed and the square root of y are attached by multiplication, so that multiplication will turn into the addition of two logs, and then this division sign here will turn into subtraction of log z squared. So this is going to become log of x cubed plus log of the square root of y subtract log of z squared. And these all have the natural log 10 because I didn't put a number after the log. And finally, all of these exponents here can come out front. And as a reminder, the square root of y can be written as y to the power of a half, right? So we take the index of the root, so this is a square root, and we put that in the denominator of the exponent. If it were a cube root, it would be a third, and so on. And I'll bring that front. So I'm going to have 3 times log x plus a half times log y minus 2 times a log z. So here I expanded it out. Now I can also go in the opposite direction where I take an expanded version and I turn it into a single logarithm, and I can only do that if I have a common base. And I just noticed I have a little typo on this one as well because I didn't match all of my bases. So I'm just gonna go in here and add the little base 3's for all of these examples. So I need to write this as a single logarithm. So first thing I'm going to do is take any coefficients and bring them up into the exponent of the argument. Now this constant of 2, I was told to turn it into a single logarithm and nothing more. I need to turn 2 into a logarithm as well. So I need to write log base 3 of something so that it's equal to 2. Now a reminder that logarithms, the answer to a logarithm is an exponent. So 3 to the power of what would give me that box? And the answer is 2. So 3 to the power of 2 is 9. So that would be my argument. Log base 3 of 9 is 2 because 3 to the power of 2 is 9. So there we go. I turned something that was actually very basic and turned it into a log just because the end goal is a single log. Then I'm going to take, like I said, those coefficients and bring them up to the exponents. Now an exponent of a half, I would rather write it as a square root. That looks cleaner. And then y plus 2 cubed, and then log z. Okay? And now anything that's attached by addition, those arguments will be multiplied. So that means the 9, the root x, and the z will all be multiplied because they all have addition in front of them. Whereas the y plus 2 cubed, because there's subtraction in front, that will go into the denominator because that's what we are subtracting. So log cubed, and then my numerator will have a 9 root x, and z, all divided by y plus 2 cubed. And that, is our answer. And this is a single logarithm now. Okay, so those are our log laws in both versions, expanding and simplifying. Now I realized I don't have any evaluating logs, so I'm just going to add a couple just on the side here. So we'll start with the following. Log base 5 of 1 over 25. This is asking the question 5 to the power of what equals 1 over 25. Now, as a reminder, a question like this, if you just tell me what the answer is, that's not any marks because some calculators just give you the answer. I need to see some work, and that's what I'm showing here. And now I have to think, okay, 5 to the power of what is 1 over 25? Well, how do I get a fraction? A negative exponent. Okay, the negative will give me a reciprocal, and then I know 5 to the power of 2 is 25. So if my exponent was negative 2, the negative creates the fraction, the 2 gives me the 25. So our answer is negative 2. Okay. If you have a more complicated one and, you know, just seeing the exponent off the top of your head is hard, there is another strategy we can use, which is getting a common base, because this is just an exponential equation. So I'll do one that's a little more complicated. So let's say my base is a third. Actually, no. Let's say my base is 27, and then I have a third as my argument, log base 27 of a third. And I'm trying to see, okay, 27 to the power of what gives me a third? Instead of putting that little box, we can just say x, 27 to the power of x equals a third, and now we're just solving an exponential equation, which means let me get a common base. When I see 27 and 3, I think of 3, so 3 cubed is 27, and that was all to the power of x, and a third can be written as 3 to the power of negative 1. Now, 3 cubed all to the power of x is the same as 3 to the power of 3x. And thinking back to exponential equations, the minute the bases match, you can just set your exponents equal to each other. And then when I divide both sides by 3, I get negative a third. So that means log base 27 of a third is negative a third. 27 to the power of a negative number gives me the reciprocal, and 27 to the power of a third tells me to take the cube root of 27, which is 3. So that actually works out really nicely. So evaluating questions are also things that we did in this unit, and just reminding everyone that, you know, you have to show your work, because if you just give me the answer, that's not really showing me any of your knowledge or any of your thinking. So there's that. Any questions before I go on to the graph? Okay, perfect. Let's go to our graph. We're going to graph f at x equals negative 3 log base 3 of 2x plus 10 plus 4. So first thing we want to do, if the k value, which is 2, is not factored out, we want to factor it out first. So I'm going to factor out the 2, which gives me x plus 5. And now I'm going to do a table of values for the base function. Just going to do that on the side here. And the base function is y equals log base 3 of x. We don't have the a, the k, the dc, none of that is there. Now remember, when you're creating a table of values for a log function, you want to convert it into exponential form because it makes it a little nicer to deal with. So 3 to the power of y is equal to x. And because y is in the exponent, I'm actually going to start off by picking my y values. And now to get x, I just have to evaluate 3 to the power of that value. So 3 to the power of negative 2 is 1 over 9. 3 to the power of negative 1 is a third. 3 to the power of 0 is 1. 3 to the power of 1 is 3. And 3 to the power of 2 is 9. So those are my base points that I will put through the mapping rule. Now, remember the mapping rule? Yes, you can memorize it, but it does come from the logic of the transformations themselves. So your x coordinate is affected by everything horizontal, which is in the bracket. Now, in this bracket, the 2, remember we have to take a reciprocal. The reciprocal of 2 is a half. If I multiply something by a half, I'm making it smaller. So this is a horizontal compression by a factor of a half, which means my x values should get multiplied by half. And then the x plus 5 tells me to go shift left 5 units. And if I'm going to the left 5, I have to subtract 5. So there's the mapping rule for x. Y is affected by my vertical transformations. So the negative does a reflection over the x-axis, and I'm doing this very short form because the question didn't ask me to state the transformations. If it did, I would be writing what I'm saying out loud. Reflect over the x-axis. And the 3 is a vertical stretch by a factor of 3. So my y value is going to get multiplied by negative 3 to accomplish those two transformations. And the plus 4 is up 4, so I'm going to add 4. So now I'm going to take all of these base function points and put them through the mapping rule. And when I put them through the mapping rule, I don't have to keep the fraction. I can write the decimal so I can visualize the point better. Okay, so I'm going to do 1/2 times 1 over 9, subtract 5. And that's negative 4.94 repeated. Then 1/2 times a third minus 5 is negative 4.83 repeated. Then 1/2 times, 1/2 times 1 is negative 4.5. 1/2 times 3 is negative 3.5. And finally, 1/2 times 9 minus 5 is negative 0.5. Now I'll take all of my y's and put them through the rule. Negative 3 times negative 2 plus 4 is 10. Negative 3 times negative 1 plus 4 is 7. Negative 3 times 0 plus 4 is 4. Negative 3 plus 4 is 1. Negative 3 times 2 plus 4 is negative 2. And now I'll go ahead and plot these points. Now, before I plot the points, we also have to remember that a logarithmic function has a vertical asymptote. The asymptote used to be on the y-axis, but the right-left movement is what will affect it. So because we're moving left 5, I am going to have a vertical asymptote at x equals negative 5. And you could also think of your vertical asymptote in terms of the restriction on the argument. The argument has to be positive. Any number greater than negative 5 will accomplish that. And that's what the vertical asymptote is doing. Everything's going to be to the right of it. So now I'm going to plot my points. Negative 4.94, 10. Negative 4.83, 7. Negative 4.5, 4. Negative 3.5, 1. and negative 0.5 comma negative 2. And then I will connect my dots. Now, if I wanted a little bit more accuracy and I wanted to know exactly where my x and y intercepts are, I can definitely solve for those values algebraically. So for my y-intercept, I just need to evaluate f at 0. So I'm just going to go to my calculator here, negative 3 log base 3 of 2 times 0 plus 10 plus 4, and I got negative 2.3 approximately, which, yeah, decent. That's kind of what I did. If I want my x-intercept, I can set y equal to 0. And then solve for x. So then this becomes a little refresher on how to solve a log equation. So first thing I'm going to do is bring the 4 to the other side. It becomes negative. Then I'm going to divide both sides by negative 3, which will give me positive 4/3 now. The minute I have a log equals a number, I can convert it into exponential form. So the base will stay the same. So it's going to be 3 to the power of that 4/3 equals 2x plus 10. I am just going to plug 3 to the power of 4/3 in my calculator to get approximately 4.3, let's say. And now I can finish solving this linear equation. So I'm going to subtract 10 from both sides. And then I'll divide out the 2. And there's my x-intercept, negative 2.85, which is actually roughly what I plotted. So here is a potentially very full question because you have to refresh on your transformations, your mapping rule, figuring out the base function coordinates. I did a little bit of x and y intercept refresher as well. And once you have your x-intercept, you can even talk about, well, here's my positive interval from negative 5 from the asymptote to negative 2.85, and then I have a negative interval from negative 2.85 all the way to infinity. This function only has an interval of decrease. The domain is from negative 5 to infinity, whereas the range is infinite. Okay, so that is a pretty full question there. And the final example for tonight is a fuller solving question. So I have log base 4 and then a quadratic argument minus log base 4 of negative x equals 1. Now, before I do any of my solving, I'm going to do my restrictions first, just on the side here. And with our restrictions, we need to take the original arguments one at a time, and I need them to figure out the values when each argument is greater than 0. So I need this one to be greater than 0, and I need negative x to be greater than 0. I'm going to start with the negative x one because it's a little quicker. So I have negative x. I want to know what x has to be, so I'm going to divide both sides by negative 1. And when I divide out a negative number, I have to flip the sign of my inequality. So that's telling me that x has to be less than 0 for the second log. So I'm going to show that visually. There's my first restriction. Now I'm going to go to my first log. Sorry about that. That was my email. When it's a parabola, I have to factor. And then I'm just going to sketch the parabola and see when the parabola is above the x-axis. So it's just a very rough sketch. My intercepts are 8 and negative 2 for my factored form. The parabola is opening up. Here it is. And now I'm going to highlight the regions where the parabola is positive. So that's this portion here and this portion here. And that restriction is x is from negative infinity to negative 2 and from 8 to infinity. So I'll show that on my number line. So negative 2 is here, and positive 8, let's say, is here. Now remember, when we're talking about the restriction of an expression or an equation, we want the restriction that is an overlap of both restrictions. So this piece here is useless because it doesn't satisfy the red piece. So that one, no thank you. But I see an overlapping region right here. And that's when x is less than negative 2. So my overall restriction, I can write it either as x is less than negative 2, or I can write it as x belongs to negative infinity to negative 2. Whatever format you prefer, either one is fine. So I'm going to keep that in mind for when I finish solving, because I might get some answers that don't belong in the restriction, and then I have to cancel them out. They would be extraneous. So let's get into the actual solving. So because I have two logs with subtraction between them, I'm going to use my log law to turn this into a single logarithm where I'm dividing. Now, normally I would factor this to see if anything would cancel out, but because the denominator is negative x, and I know it factors to this right here, nothing's going to cancel. So I'm not going to factor. I'm just going to convert this into exponential form. So 4 to the power of 1, which is just 4, is equal to the argument. Okay, 4 to the power of 1 is 4, so I'm just going to erase that little 1. And now, because this became a rational equation, I just have to cross multiply here. So I'm going to put the 4 over 1, and now multiply. So 1 times the quadratic, and 4 times negative x. And now I have a quadratic equation, so I need to bring everything over to one side and either factor or do quadratic formula. So I'm going to add the 4x. And this here, to get to 16, 1 times 16, no. 2 times 8, no. 4 times 4, no. So I am stuck with a quadratic formula here. So x equals negative b. b is negative 2, so 2 plus or minus the square root of b squared minus 4 times a, which is the invisible 1, times c, which is negative 16, all over 2a. And now I'm going to clean this up. I'm going to clean up the part under the square root and the denominator. And I got 68. The fact that I got a number that's not a perfect square under the square root tells me that this wasn't factorable. And now I'm going to punch it into my calculator. 2 plus the square root of 68, all divided by 2, gives me approximately 5.1, but my restriction says I have to be less than negative 2, so this one is extraneous. Although it was a solution to the parabola, the quadratic, it doesn't actually work for the logs, because imagine taking this 5.1 and putting it into this argument. That would become negative 5.1, and we can't take the log of a negative number. Okay, and now I'm going to try the other version. So to subtract the square root of 68, all divided by 2. This one I get negative 3.1. That is much better because it follows the restriction. It is a number less than negative 2. And there we have it. A little bit of solving review, restriction review, graphing, laws, evaluating. Now we did also, this isn't everything we did, but I'm trying to go over the key things from each unit just to get you started with your review. We also had a few little applications related to logarithms with the Richter scale for the magnitude of an earthquake, for pH, for loudness. We had some exponential word problems in solving as well. Okay. So, in terms of our review, I just want to highlight, if you were following along yesterday doing the polynomial and rational, I'm going to just highlight what the goal for tonight should be. So, in terms of graphing, I have an exponential, a log, and a log in questions 5, 6, 7. In terms of solving, I have some exponential solving, some logarithmic solving from 15 to 19. We didn't do any inequalities there. I have an exponential word problem for question 35, and another one for 36, and a loudness question for 37. And for the other problems, we have some logarithm laws and restrictions for questions 41, 42, 43. That's trig. And there we go. Okay, so like I said, if you're following along with kind of the schedule, doing your polynomial rational review yesterday, and now you're doing your logarithm and exponential review, the ones I highlighted just now would be the goal for tonight. And then tomorrow, I'm going to do the final little review on trig functions. I'm not going to do any review on the combined functions just because that is our most recent unit. It should be the most fresh in our brains. But yeah, that's it for tonight's review. I'm going to stop the recording right here.